Hello, everyone, and welcome to the launch webinar of GigaSpaces Extreme Application Platform ZAP 7.0. Today, we'll hear from GigaSpaces CTO about the vision and the highlights of ZAP 7.0. We will later on hear from Kees de Groot, the lead architect at eBay Marketplaats, about his experiences with GigaSpaces ZAP. Please feel free to send your questions during this webinar through using the chat tool. We will respond to your questions during the webinar as well as at the end during the Q&A session. I wish you an enjoyable and interesting webinar and urge you to fill out our survey at the end of the webinar. Your inputs are extremely valuable to us. So with no further ado, I'll pass on the mic to Nati Shalom, GigaSpaces CTO.
Hello, everyone, and I'd like to start with the introduction of GigaSpaces, starting with a vision, where we're going to, where we see the market is going, and obviously talk about some of the stuff that we've done in 7.0 release, which obviously correlates with that vision. I'll start with going through what is the market view, and then dive into some of the features that we added in the 7.0 release. Towards the presentation, I think somewhere in the middle, I'll switch to a case where you can actually talk about specific experience, his experience on building an e-commerce site. I think the case itself is going to highlight some of the interesting aspects of how you actually implement a large-scale application using the technology. So I think that the two together will hopefully give you a good understanding of not just what's new in 7.0, but how that helps you to build a scalable application. I'll start with a quick intro to, again, the vision of where we are. And as you could see by the customers that are using GigaSpaces, we've been used fairly in a very highly demanding application in a large-scale organization, very high-end organization, both in the financial world as well as in the telco world, and now also in the e-commerce application world. In general, what we're basically aiming to, and that's the main target that we're trying to solve, is how to make scalability simple. Essentially, the idea that we're trying to convey is how do you take a distributed application and run it in a cluster of machines as if it was a single machine. So from a code perspective, from an application developer perspective, it should be simple, but at the same time, we could give you the power of distributed computing, the power of the fact that you can take multiple machines, commodity hardware, and get the flexibility aspect of it injected into your application. If we look at, again, the vision behind that concept, that's not really new. That's where the market is actually going to. That picture was actually driven from a Forrester report. And essentially, it talks about where the data center, the next generation data center is going to look like. And basically what it shows is that we're moving from a scenario where we have an application running as a silo on a dedicated set of hardware into a scenario where we're going to have a demand and resource matchmaking in a much more efficient way. That basically means that application creates a demand. Then at the bottom, we have the actual hardware resources. And in the middle, we'll balance between the demand and the resources based on utilization, which means that we're not going to have this silo type of implementation where each application is running on its own dedicated resources, even if they are not really using those resources. And obviously, there is a lot of benefit that comes with it, the efficiency, the cost effectiveness, the power cooling, and all those type of things that you want to gain by that model. The gap is that if we look at today's middleware, what we'll see is that in the infrastructure level, we do have things like virtualization that enable us to create machine and an API call. We have cloud computing, again, as an infrastructure that enable us to get machines in a non-demand basis. But if you go up the stack towards the application, what we'll see is that today's middleware are not really geared to provide services to the application that will enable them to take advantage of those new infrastructure. Just think of a scenario, what will happen to your application if I'm adding another machine in the network? Will it be able to take advantage of it? Will it be able to immediately span itself when it needs to into those new machines? Usually today that involves a lot of manual work, and in many cases also changes to our code. What we do expect from middleware is really to provide us the core services that middleware should provide: fault tolerance and self-healing, linear on-demand scalability, high performance, and obviously the ability to manage that, especially when we're talking about a distributed environment. That becomes even more important than in a standard client-server mode. And as I said, the main challenge that we're seeing today is that most of the middleware that exists today does not really address that problem, and obviously that's an opportunity, and that's where GigaSpaces fit in. So GigaSpaces really is all about addressing that problem and providing the middleware that can take advantage of those new level of infrastructure, take advantage of this highly distributed application without, again, exposing a lot of the complexity to the application developer. The secret sauce, as we call it, behind the concept of GigaSpaces is not new. It's something that was actually developed in Yale University back in the late 80s by a professor named David Galenter. And the project was named Linda. The basic idea was to create a shared address space, in-memory address space, that will enable the distributed application to share and exchange data between themselves or coordinate actions without knowing where each instance, where each application really resides. With that, I think that added the capability to really virtualize applications that are running on a dispersed set of machines and let them communicate as if they were running on one machine. And that being one of the core concepts behind the idea of GigaSpaces when we started GigaSpaces. The other thing that we've done once we started with that model is to really take a few steps further and make that shared address space scalable. And that's really where we started to add a different type of implementation. Rather than having a shared center for that space, we created partitioning. We added the ability to collocate the application business logic with the data, and all that enabled us to build an architecture that ensures and can guarantee linear scalability. And that is something that we'll probably talk also on the Marketplace case study later on. One of the main things that we wanted to do in 7.0, and some of you already know our caching story or data grid story, where we solve the scalability of a specific application, or specifically the data bottleneck. In 7.0, what we really wanted is to look at the end-to-end flow of a transaction. And if you look at the top part of the picture, what you'll see is that a normal user interaction goes through those different hops, where it goes from the browser to the web server, and then from the web server to the application server. And each application server has its own backup, so it also goes to its backup. The messaging is also written as a separate system, so it goes to the messaging. And we have all these hops between the user and those different subsystems to fulfill a single user request. Meaning, when I click on the browser, this is usually the things that I'm touching during the transaction flow. Now, obviously, if you look at that from a user perspective, from a latency perspective, from a complexity perspective, that in itself imposes several problems. One is we have a lot of moving parts, which means that our application is not simple. And if we think about scalability and adding more resources, we're also going to get in a very complex scenario where we'll have to scale on those multi-dimensions. So if we want to scale, we'll have to figure out how we scale on the application server, how we scale on the database, how we scale on the messaging. And then even if we do that, we're always going to be as strong as our weakest link. It's going to make us pretty busy on tuning that system. The other thing from a latency perspective is that we're going through all those network hops, and because every tier in our application doesn't assume anything about the other tier, it tries to implement its own clustering for maintaining its high reliability, which basically means that we have a lot of redundancy in the system and a lot of overhead in terms of the network calls, because each one of them needs to maintain its own backup. And therefore, we have a redundant call to a redundant system just to maintain that backup on a per-tier basis. Now, one of the benefits with GigaSpaces is that we realized that, and unlike the previous releases, we wanted to really look at the end user flow. What does that really mean? It means that we obviously reduce the number of moving parts, and that's a lot of that was gained using the space-based architecture that I mentioned earlier. So that really covers a lot of that piece. The second thing that we wanted to do is really reduce the time it takes for the user to access the database. So for that, we added the data grid. Then to maintain the scalability at the front end, what we really need is obviously the integration with the load balancer that will enable us to fulfill a dynamic scaling at the web server layer, but also make sure that the user session doesn't go away when we remove web servers. And when we route the user for different servers, we really want to make sure that the user doesn't break its experience and doesn't need to restart its entire session. So we need to make sure that the session itself is also highly available. So with all that, we can really enable scaling from the web to the database using one clustering technology, one high availability technology. We've been able to reduce a lot of the moving parts in the process just because we changed the philosophy of how we treat clustering. We're not looking at clustering as something that is dealt on a per tier basis and a per product basis. We look at that as a holistic solution that covers the entire universe of the food chain, if I would call it that way, of the user interaction. And that's, I think, leads me to the second item of the release, which is the patterns. I've heard and I've read a lot of the hero story of users that are building a large-scale web application, the Twitter of the world, the Dig of the world, and all of them had to go through a lot of effort to build their application. And they had to choose a lot of different packages and different software packages and glue them together somehow, memcached, and then some sort of a remodeling mechanism and some sort of a asynchronous web mechanism. And if I just looked at LinkedIn, they also implemented their own messaging mechanism. So that's a huge effort. That's a really huge effort. And in many cases, it works individually, but if you try to glue them together, they start to break. And we realized that a lot of people are going to go through that experience, and rather than pointing them to all those different solutions, we came up with a set of patterns like partitioning, asynchronous web, MapReduce, NodeDB, which basically means that the database is pushed behind. It's not really going completely away. As part of the implementation itself. So when you need to build the application, you don't need to look for other solutions. So that's kind of the other thing that we added in the release itself, and with that comes all the benefits that you could see here at the bottom. The other thing is the performance itself. If we look at the performance, one of the things that we really wanted to gain is the multi-core capabilities. With the new hardware that we have today, we really have a lot of cores, but in many cases, writing an application that can exploit these capabilities requires a skill set of writing concurrent programming, which is fairly hard. What we really wanted to do is two things. One, obviously implement or change our implementation, or optimize it to a level where we can really exploit the power of multi-core. And as you could see by the numbers, we were able in the 7.0 release to improve that by a factor of 300%. The other thing that we wanted to do is expose that power to the application without letting the end user know too much or program too much concurrent programming. And that's built into the concept of what we call polling containers and the built-in concurrent programming that we have in our system. So basically that means that you could gain that power without needing to go down to the level of optimization that we had to go through, and some of the things that you'll have to go through if you go with alternative solution. The other part is the administration API. I wouldn't go too much into the details of that, but basically the administration really gives you the power to not just monitor the system, and that's pretty new in 7.0 release, but also take actions. The reason why it's very important and very core to our concept is because if you really want to have a large-scale application, you can't really assume that you need to do manual work to maintain that system when something goes wrong. it has to be automated. The deployment of that application needs to be automated. The self-healing needs to be automated if you really want self-healing, or if you really want the application to deal with failures without human intervention. It also needs to behave automatically to scaling events, because you can't really assume that you're going to get a call just to add another machine and expect the system to load. In many cases, in a large-scale system, that's not going to work. You also need to assume that things will go wrong. So rather than providing a black box approach where we deal with all that, we realize that we can think of the algorithms and probably come up with a set of algorithms that will come as part of the product, but you will need to gain access and control over that environment yourself. And without giving you the control, there's so much we can do with that. So we did two things in 7.0. One is provided the control, the API, to enable you to take advantage of and control the entire part of the system and write your own SLA, write your own scaling policies, if you like, and your own automation script, but also provides the extended monitoring that enables you to get access to more data and monitor the system in real time. So that really gets me to the last part of this session before I move to case, which is where we're going from that point. Towards the next release, we really wanted to continue the path of making distributed applications simple and as seamless as possible. For us, if we can make any application scalable without touching your code, that would be the ideal world. So obviously, standard support is important with the new J2E spec that is much more similar to the Spring Notion. We believe that we can support a large part of the J2E spec and therefore enable it to avoid any vendor locking potentially. The other thing is security, especially when we're talking about a multi-tenant environment where a multiple application is going to access the same shared infrastructure. That's going to be a very important part and actually a very unique part, I think. The other thing that is obvious, and I think that many organizations are going to go into that model where we really want to exploit the fact that we can distribute the data across multiple data centers to save latency. If we really want our users to experience low latency on our sites, then we'll have to replicate some of the data to avoid the geographical latency that comes with it. And in addition to that, we'll continue the path of adding more built-in SLA and enhanced queries capabilities. And I didn't mention here because I think it's obvious, we're going to continue the path of improving performance and stability, et cetera, et cetera. So I think that gets me to the case presentation. Alit?
Thank you, Nati. So let us move on to case. Just 1 second. All right. Okay, Case, the stage is yours.
Thank you, Alit. Good morning, everyone. This presentation, which I'm trying to keep as concise as Nati's, so we can keep plenty of time for Q&A, I'll give a short overview of what we're doing with GigaSpaces and why we're doing it at Marktplaats.nl. If you're coming from the Netherlands, you probably know already about Marktplaats.nl, but this is an international audience. I'll try to quickly run you through what we're doing. There's a pretty long agenda, but I'm quite sure we can make it in like 20 minutes. If you have any questions, feel free to enter them in the chat, and I'll try to answer them as quickly as possible. First, a short introduction. What I'm doing here, I'm working, and that's actually, if you look down the slide, I've been working with GigaSpaces-like environments since the late 90s when Genie was introduced by Sun, and I had to architect an application server. At the moment, I'm working at Marktplaats as a sort of lead architect, leading up in both the agile conversion and the conversion from the current platform, which we'll go into in a bit, into something that's more potent than what we have. Nati already pointed out that a lot of websites that have grown organically have a lot of architectural problems, and I hope that I can make a nice example here. Okay, Marktplaats. For those who don't know it, Marktplaats is the largest e-commerce site in the Netherlands, acquired by eBay 4 years ago for a pretty hefty amount of cash, and we're actually the first one in the eBay portfolio that made up for that deal. And eBay, by the Marktplaats case study, has decided to broaden its activities on the market of classified sites. And in the Netherlands, we have a reach of like 90% of everyone in the Netherlands is using Marktplaats at some time. We're doing mostly C2C business, a lot of B2C and even B2B categories are appearing on Marktplaats and growing like crazy. And one of the things we wanted to do with Marktplaats is to enhance the possibilities for advertising. And this is what the case study is all about. So, Marktplaats at the moment is mostly LAMP sites, Linux, Apache, MySQL for data storage, and PHP for programming language, which is a very nice architecture to get you started. But if you have 500,000 lines of code in PHP and a lot of transactions per second, you're really starting to feel the limits. And now I clicked one time too much. So what we're looking at today is AdMarkt, which is, for those who are into web advertising, a very well-known model. We have regular advertisements on Marktplaats. Regular listings can be enhanced by all sorts of features, but we wanted to offer something different for especially B2C advertising, which is a pay-per-click pricing model. If you look at the screenshot on the top right-hand side, you'll see a highlighted box of 3 listings, and these are pay-per-click listings. So they're mixed on top of the regular result sets if you're searching on Marktplaats, and advertisers pay-per-click. And we targeted small and medium businesses, large companies, like a couple of really large retailers are using it, and media agencies, search engine marketing services are using this service to offer to their clients again as well. So they appear on every results page, which means that everywhere that we serve a result listing, which goes into, I think we're peaking near the thousands per second, we also need to serve up these AdMarkt ads. We launched AdMarkt 2 years ago based on a prototype, and in the meantime it's grown like crazy. We have more and more customers than we ever thought possible on such a short notice, and especially the number of impressions per second is really impressive. Of course, with success always comes a downside. And that's that you need to, if you have thousands of impressions per second, you also need to do thousands of click and impression registrations per second, and even impressions are currently in the tens of thousands, because you got like multiple impressions per search page or listing results, search result page. And that means that we need to do a lot of real-time calculation. And if you look at the platform we implemented Outmarked on, which is Linux, Apache, MySQL, PHP, then all you can do, and that's what we're doing at the moment, is store the data into the database, and then have regular batch jobs that are running like every 5 minutes, churn to a massive amount of data that we collected in 5 minutes, and we're churn through them. And it's clearly not what you want. The business wants real time. The business wants click fraud protection algorithms that also operate as near as real time as possible to make sure the fraudulent clicks aren't registered, etc., etc. So we had some architectural challenges ahead of us when we decided to rewrite Outmarked. I'll skim through the current architecture, and the most important line probably at the moment for most large websites is the bottom line, which is the immense power bills you're getting if you have hundreds of servers. No one at our company is really interested in the capital expenditure of all these servers because it costs like €1,000 per piece, and you can write them off over 3 years. But the power bill is really starting to hurt our bottom line. So one of the things we really want to get rid of is this humongous cluster where every machine has a specialized role. It's either a database or a batch machine or whatever. That was one of the ideas for new architecture. Some technical details about the biggest issue we're having with the current architecture, apart from PHP, which is really slow in execution, and it's not really as scalable as a lot of people believe, is that the typical database model is that you have sort of master-slave configuration, where the master gets all the updates from the website, and the slaves serve all the reads to the website. This works in principle really well because you typically have a lot more reads than updates. But if you look at the arrows, all the slaves can do all the updates, and especially in MySQL where replication is a bit primitive, this takes just as much time as it would take on the master. So there's no optimization done for replication on the master, which means that if the master is like 50% loaded doing writes, all the slaves are 50% loaded doing writes and can only do 50% of their capacity to do reads. And we already met this issue a couple of times where slaves were simply saturating with updating their data and have no spare capacity for reading. And then you go to, well, manual solutions like doing caching, doing partitioning manually, federation, splitting of data sets. We use SQLite for local caching, etc. If you want details, feel free to ask. I won't go into it too much. And the whole idea of having all these various service roles is probably exemplified best by our QA environment, where you have like 1,000 VMware machines to replicate a handful of production environments. I'm having some delay here, sorry, with changing slides. Okay, so we set out to solve, well, not some of PHP's issues, but actually most of PHP issues. A huge performance and throughput requirements so that we could really cut down on the web cluster, but at the same time also some upgrades on the requirements of our developers. We require our developers to have Java certification on the programmer level to make sure that our workforce, has some common understanding of Java. One of the things we also want to do is keep it manageable at the current level, but be able to grow 5 to 10 times without having to increase maintenance, especially site operations, and get rid of a lot of our hardware. And early on in this redesign, it was like a year ago, we already noticed that, well, the only way you can really do it is to remove the database and go to a memory-based solution. So we made a shortlist last year, and we settled on 2 providers that we wanted to talk more with, Terracotta and GigaSpaces. We had people over from both vendors and very interesting discussions. And frankly, it was a really, really tough call, except for a couple of things that made a huge difference to us. If you look at the core thing about Terracotta and GigaSpaces, Terracotta is a distributed JVM clustering technology, and GigaSpaces, there was also a difference in how we got approached by both vendors, where Terracotta was about technology and GigaSpace was talking about problems and solutions. So GigaSpace was talking about, okay, how are we going to interface with load balancers, with virtualization environments, etc. So how are we going to make your operational life easier? And Terracotta was mostly about, okay, how are we going to give you a huge, big JVM, which is virtual, distributed, and seems to operate like a single one. And then all the rest of it, you basically still need to solve yourself. And as we had a developer force that was mostly trained in PHP and, well, retrained in Java on short notice, and at the same time, from my Java experience, I know that concurrent programming in Java is like really, really hard. I've seen multiple, we've been using multiple open source libraries which we needed to rip apart to get some high performance out of it, because the most basic concurrency errors were made there. GigaSpaces really had a huge advantage there by providing an API for, well, most, if not all, distributed problems we were going to tackle. And a couple of buzzwords now, like MapReduce and stuff like that, and that's all in GigaSpaces, and you can all solve it with a couple of lines of code, which wasn't the technical version of this presentation, but I'm happy to say I'll skip that. We can skip that bit. So the reason for GigaSpace for us was, GigaSpace was talking about providing solutions instead of technologies, and I'd rather pay for solutions, because technologies, in the end of the day, you can get them pretty much anywhere. And GigaSpaces provided a clear API and clear rules, like, okay, if you got that sort of problem, you need to do that, and if you got that sort of problem, you need to do that, which really helps guiding our developers. And if you look at what we have in terms of framework over GigaSpaces, it's well, maybe 10 or 20 lines of code, and it's mostly a couple of agreements on this is how we structure our code. But we didn't need to add anything over GigaSpaces. Still trying to click onto the next slide. Can you do it for me, Alice? Thank you. So where we are now, we have simple codes, simple annotations, and it really results for us in a powerful distributed system, which works as promised. Most of the work that is really performance would really be a performance bottleneck is done in memory and local to a JVM, so the data and the processing are done in the same place with a minimum of network calls, which means that it's awfully fast. And we've already seen and worked out for ourselves that, yes, indeed, if we just need to upgrade scalability, we repartition the data in more partitions, and we can just parallelize, well, really without a lot of speed bumps inside. There are always, in any architecture, there are a couple of speed bumps, but one of our architecture requirements were we were able to scale like 10 times over the current volume, which means that we should be able to go to the hundreds of thousands of impressions per second. and it looks like easily attainable without re-architecting. So, some results quickly of where we are now. As soon as we had all the components in place, like click impression tracking and our click fraud protection program, etc., I did some testing on my laptop, which is a Dell A30, a Core Duo, 4 gigs of RAM. Everything was locally. Grinder is a load testing package we're using. 2 GigaSpace containers. GigaSpace equipment management was running locally. We inserted 1,000 ads, and really to my surprise, we were able to handle 25k ad impressions per second on that system, which is more than double the current production loads. And the production load, I can tell you, is running on a bit more hardware than a single laptop. Our production environment is 8-core Xeons with 32 gigs of RAMs. So double to quadruple the throughput should be doable, which looks like we can make 100k ad impressions per second on the initial production cluster, which means that not only we don't need to re-architect our application to make a factor of 10 increase. We wouldn't even need to procure new hardware. Of course, no, there is no silver bullet. GigaSpaces under the hood is still a distributed system, so I want to close with the slide with some caveats, because if you just step in blindly and start using GigaSpaces and have total neglect for what's happening on the network, etc., you're more than likely to shoot yourself in the foot. Notice the distributed computing, if you're inclined into reading computer science papers, is the philosophical underpinning of Genie and Java Spaces, and I think a lot of inspiration of GigaSpaces came from there as well, which makes a very strong case that whatever beautiful software you put on top of a network, you can never completely hide the network. So with GigaSpace, you need to think about where is the data, how are you routing, etc., etc. Also, we learned that GigaSpace is a bit different. If you port J2E applications, it's really not too different, and you can do it in half a day. But if you really want to go the full way, you need some training and really need to think a bit different about patterns you're using than what you would usually do. And what we learned is that setting up an automated performance test suite really, really early, and it's in agile development environment, I would say in sprint 1 or 2, that learned us that the first version of our impression code was like functionally correct, but we scaled up to, I don't know, 500 or 750 impressions per second because we made some errors in routing. And it really helps us at the moment evaluating on a continuous basis, okay, we made this decision, we added this code, and this is the impact. I think I'm out of time and out of slides. So I think, okay, a couple of next steps. That's the last slide. Now I'll go back to Alit. At the moment, we're mostly code complete as far as the foundations are, so we're now building up to make everything smooth for customers, mostly user interface work, and we're going to roll out this quarter, hopefully. It's still an IT project, so I'm adding the hopefully. After that, we're already ramping up a full rewrite of markbats to Java, and an estimate of the savings is like we will be able to slash 2/3 of our web and database cluster, which amounts for us for a couple of hundred machines. And well, GigaSpace licensing fees are steep, but in our calculations they're more than worth it, because with these savings, including the main years of effort necessary to convert markbats from PHP to Java, will have a return on investment in like two years, and that's mostly on hardware and especially electricity savings. One of the things that I want to give up as a closing advice is, don't rewrite in full in GigaSpaces. There's a lot of potential to help you smooth the transition. If you're a Java application, you can basically redeploy in GigaSpaces and slowly add caching. But even if you come from a completely different environment, there are plenty of possibilities to use GigaSpaces as the database instead of the database, etc. So that's the way we are going to tackle it, and that's the way I'm quite sure we'll be successful. Which is the end of my presentation.
Thank you very much, Kees, for your presentation. We already have a few questions, but just before we go to these questions, Nati has a couple of summarizing slides for you, and we'll move on to the questions that we have. So, Nati, let me just make you a presenter.
Thanks very much. And by the way, Kees, thank you for the very good presentation. It's always interesting to see when I hear that presentation to learn more things than I knew before. I did learn a few things. I hope the audience learned a few things as well. Anyway, this is the concluding part of the presentation. As Alit said before the actual questions, I wanted to touch on the last bit that Kees was talking about, which is the ROI. We often, as the techie guys, we often look at technology as a way to solve scalability problem, but what we often forget is that there is also a business need behind the application, which is to do that efficiently. And therefore, as Kees mentioned, the software cost, the software license cost, is only part of the total cost of ownership of running our application. So if we broaden our eyes a little bit and look at the broader application context and the cost involved in building application, we can actually see how technology can help us to make our business more efficient. And basically, we came up with this list of items that will enable you to improve the actual cost of your application. One of the items, which is the performance itself, basically means that you could use less machine to achieve the same throughput or the same number of concurrent users on your system with less hardware. The fact that you could make your application more reliable by removing a lot of the moving parts, and statistically, large number of the sites and large number of the cases where sites have facing crashes and stuff like that, is not really a result of an error in the application. It's mainly a result of misconfiguration, unoptimized deployment, etc. And the spare capacity is also an interesting thing because we added the dynamic scalability into our application, and most of the current applications are really provisioned by the peak load. Now, if you look at that and just measure how many resources are underutilized just because you're not flexible enough in your architecture and you provision things for the peak load, you'll find that that's really the main reason why you're underutilized. If you could really provision for the average load and not for the peak, and pool machines to serve your peak load only when you need to, that in itself has a huge factor of saving. We estimate by a factor of 5, in some cases a factor of 6. The other thing is the multi-core that I mentioned here. Again, it's the ability to take advantage of the hardware and squeeze more of the existing hardware by making the application layer more efficient. And that basically ends up with the fact that we need less machines to deal with our application or to meet our performance requirements. As Kees mentioned, the fact that you can reduce the complexity of the development is also saving you the development cost. And in many cases, modern development costs enable you to get on time and reduce the time to market of your application, which in some cases would be a huge factor of saving. Because then, compared to your competition, you could be at a very different case. So that really summarizes, I think, what we've been doing both in 7.0, and as you've seen, this has actually been working for customers. And in general, in our product, these are the main values that we see in the work that we're doing. the fact that we provide a single platform that can enable you to solve a lot of the problem that others would use different frameworks is a huge complexity and differentiator for us. The high performance has always been one of the key factors that drove people to look at GigaSpaces, and will probably continue to be. Our challenge is not just to deal with the performance, but actually make the benefit of the ability to inject that value to applications simpler. So doing performance and distributed computing in a simple way is probably going to be a continuous source of innovation for us and a source of value for our users. Scalability on demand, I touched on that when I talked on the ROI, and that's going to be, with cloud, better emphasized, because I think cloud also gives us the ability to not just grow on demand within our local environment, but actually pull machines from external environment to meet our goals. And the reliability is again, something that I touched when I talked about the ROI, the fact that we can reduce the number of moving parts, and the fact that we can have self-healing and the ability to move parts of the application to alternate machines when something goes wrong in an automated manner. And the fact that we added the API to enable you to gain control over what happens and do the same thing for the rest of your application is an important factor here. The open architecture is really important thing here that I wanted to conclude with. We're not trying, our value, as I said, I think several times, is really to provide all of that value in as seamless way as possible, because if we'll be able to address as many applications as possible, that would be the best case for us. So a lot of the frameworks that we're doing, integration with Spring, integration with J2E, integration with web containers, a lot of that was really to make the development experience much simpler and, in effect, get to the point where we could really inject our capabilities without you changing your code. And again, that's going to be a continuous theme in our next release. So I think that gets us to the point where we can start and address the questions. Alit? Okay.
Okay. So let me start reading out the first question we got. Just one second. Okay. So this was a question that was addressed to both Case and Nati. Case, I'd appreciate if you answered first. The question is, what do you think about the future of Java since Oracle bought it, or bought Sun?
Yeah, that's of course a very predictable question. I'm hardly a gypsy, so it's a bit hard for me to predict the future, but I think not a lot will change actually, because the industry is simply too large for Oracle to ignore, and the processes that are there are too ingrained for Oracle to ignore as well. So personally, it might slow down a bit or not. Oracle simply doesn't have an option if they want to preserve the most of what they paid Sun for, is like not for the hardware, but I think especially Java technology. And if they don't want to have an industry that is going to run away and probably fork Java or whatever, they'll probably need to just play along and move along with the current Java community process, etc. So personally, I would be hugely surprised if it would change.
Nati, would you like to add something, or do you feel that?
Yeah, I think that's a good answer. In general, I think that Java is bigger than Oracle and bigger than any vendor. It's the community, and I believe that if Oracle is not going to do something with it, then the community will probably take ownership on it. And there are other vendors that are contributing to Java, like Google and others, and IBM, obviously. So I don't think that something dramatic will happen to that. On the contrary, I think that Oracle would actually make Java better because the last years of Sun, as most people know, they were not the best years, and that led to a slower progress in the Java spec and a slower progress in some of the things. So I'm actually expecting to see things moving faster.
Okay, thank you. So we have another question, and that one asks if GigaSpaces can be deployed to EC2 or any other cloud platform. So Nati?
So I think, I'm not sure if you've seen the slides here. That's a very good question, actually, surprising even to a degree. EC2 for us is a first-class citizen. We made our platform available on EC2 directly from our website. If you go to gigaspace.com/demo, you'll see the ability to actually run all the demos of GigaSpaces in a production-ready environment in a click of a button, and that basically would run on EC2, on top of EC2. The idea behind it is in two folds. One, we believe that any customer of ours that is trying to evaluate the product will go through, the normal phases of buying machines, trying it out, installing it, and going through a lot of that complexity, and that's where cloud can make the entire experience much simpler and shorter and cost-effective. You could get the machines and build clusters and large clusters very easily using that model. Another thing that we're seeing is that other users want to use the system for deployment of their application, whether it's a prototype, whether it's a benchmark, whether it's a production application, and we already have several cases that are public on our website that talks about that.
I have another question for Case. Case, have you considered using a cloud platform such as Amazon? And what were your considerations if you have considered it?
Well, we have considered it, but briefly, for a couple of reasons. First, our in-house classifieds cluster spans multiple data centers and multiple thousands of machines. So we basically got all the infrastructure to host our own cloud, as it were. Second, of course, we're an eBay subsidiary, and as such, it's a bit tough to start hosting your stuff on Amazon, which is one of the largest competitors internationally of eBay. So that's quite simple. Amazon is completely impossible for us. Google is a bit of, well, semi-competitor, so their cloud offering really can't use as well. That would leave Microsoft, which obviously is too much lock-in and a completely different platform. So yeah, we considered it, but mostly because of competitive issues, but also because of our scale. We're not just hosting Marktplaats, but also most of the other eBay classified sites in the same data centers. And it simply is a scale that's, we got the economies of scale that we don't really need to consider a cloud solution.
Yes. Another question that we have received was regarding how GigaSpaces approach and help startups.
Could you repeat that, Alit?
Yep, the question is, how do we approach and help startups?
How do we what? I don't see that question, by the way.
Yeah, we do have it here. How do you approach and help startups?
Okay, sorry. I hardly hear it, but now I see the question, so I apologize for the delay in answering. Basically, startups for us is a key, is one of the, I would say, key users of our system. Startups that are looking for scaling and wanted to scale their application, but cannot really afford paying for the technology. That's how I would categorize startup for us. So obviously what we didn't want to happen is that you'll start to build your application in the wrong way just because you couldn't afford using the right tools at the beginning. So for us, the startup program and the entire, I would say, approach around that was to enable those users to start in the right way and pay only when they can afford it. And that's basically what we've done in the startup program. The way we help is in various ways. We have obviously the startup program, but we also have the cloud, which we believe would be something that will be even more useful than the current program. And the cloud itself reduces the barrier to entry from an investment perspective, from a cost perspective. And as I said earlier, one of the main challenges in startups is how to build your application so that it will meet the, if you're successful, it will meet your growth expectations, your dream scenario, essentially, but without going through a complete rewrite. Actually, eBay is a good example. When they started, I think one of the common story, in case correct me if I'm wrong, was that they were running on a single DLL, and they had to go through several hoops, and when they grew, to rewrite the entire application. That's a very costly experience. That's a very hard experience, especially in a competitive situation, because at that period of time, there would be others that would probably run with the right architecture, wouldn't have that delay, and therefore you may lose your market. Something that was less apparent at earlier days, but today I think is more than before. So that pretty much, I think, sums up how we look at startups and what we really want to do with them. Any other questions?
Yeah, we have one more question here. Okay, the question is, can anyone running a PHP application use your approach to scale the application?
That's probably
yep.
To whom is
That's
that?
a question for you, Case.
It depends. Marktplaats went through a number of iterations, and only in the third architecture iteration we had some modicum of layering, where we had a classical three-tier architecture with presentation layer, business tier, and data access layer. And of course, the data access layer is an ideal hook to reroute from MySQL in our case to GigaSpaces, where that's our plan. We reroute first, and then we move up in the business layer, reroute business calls, etc. So probably we are, but that's the architecture we got. We can use to leverage the openness of GigaSpace and the fact that we can deploy all sorts of web services to it without too much trouble. It depends on your architecture. A lot of PHP is single tier mumbo jumbo, and you'll have a very hard time finding the hooks in your application code to converge stuff. So that's nothing specific, of course, to PHP. That's one of the reasons that people invented multi-tiered architectures.
One last question for us today, and it's actually for you as well. Here someone is asking, how did you manage the transition to GigaSpaces, and what was the development experience and the learning curve?
Yeah, as I indicated in one of the slides, learning curve is flat at the beginning if you just start deploying servlets, but then there's a very steep part where you really need to think differently about how are you going to write your applications. And that's the part where I think GigaSpaces training comes in handily. You absolutely need that to help you help your developers make the transition. That's not something that's specific, I think, to GigaSpaces. As I indicated, you can't hide away the fact that you're working on a distributed system. So at some level, you need to think about it. The only thing is that GigaSpaces help you think in a certain way. So we went through a bit of turmoil in the project in the beginning where developers learned that. Luckily, and that's one of the cool things of introducing new technology as part of an agile development environment. You learn it pretty fast and you get feedback, in our case, on a weekly basis. So we're now, after 2 months in the project, everything was mostly clear. Okay, this is how you tackle stuff, and this is how you do it. The AdMark stuff is done with senior developers who are mostly already a bit Java experienced, helped with by some outside consultants, or Java or GigaSpace experience, so that smoothed the transition a bit for us. At the moment, we're retraining the rest of the developers to get a Java certification, and after that, they'll have their GigaSpace training. And I'm pretty sure that that plus the architecture we put in place with the smaller lead projects will have a pretty smooth transition.
Okay, I wanted to add to that is that I think that that's really one of the main challenges that I see in distributed computing in general. How do you introduce distributed computing without a lot of the complexity? And it's not just about API simplicity and making the API more abstracted, as I think Case touched on that. There is an architecture behind it. This is where, when I talked about space-based architecture is not just an API, it's a pattern. And pattern and blueprint are probably one of the most useful way to make sure that you learn lessons and others can learn from the same lessons of others. And that's how you basically get to the point where you learn from other people's mistakes and not repeating that same mistakes. So for us, we worked on two folds to address that. One of them is obviously the API, and we continue to do that, but also look at the entire application flow and come up with a pattern. By means of coming with a pattern, it also means that we have specific construct in our API that implement that pattern. So for example, we have processing unit, and we have the polling containers, all those type of things that would lead you to write things in the right way. And again, looking at the experience of how not just GigaSpaces, but distributed application were, I think, 2 or 3 years ago to where we are today, and hearing Case talking about his experience with also developers that were not knowledgeable as is on distributed computing, I think that we went a fairly long way from 2 years where I think, if you remember Case, the Genie world, trying to take those low-level API and introduce it to a common developer, I think would be significantly harder than it is today.
Yeah, I agree there.
Cool.
Thank you very, very much to everyone for attending this webinar. I hope it was indeed interesting and useful for you. Thank you, Case, for taking the time and sharing with us your experiences. Thank you, Nati. We have recorded this session, and we will post it on our website and send you an email telling you exactly where you can find it, including the Q&A of this session. We are having also another session later on today for different time zones. If you have colleagues on different time zones that you want to refer them to this webinar, please do. We will also, of course, add their Q&A session from that webinar to the one that we post for this one. So you'll get all the information you need. Feel free to contact us and have a rest of a great day.